Good day, everyone. I am Zarina A. Martirellas, and together with me are Buhia Abrinica, Cavalas Bernadette, Del Pilar Adrian Cliff, Escalera Jake, Budito Dasa, and Oro Roy Christian, and we're going to discuss 10 problems about solid geometry. Without further ado, let us now hop on to our first question.
Hi, it's me again, Abrini Kabuhia, and for today's lesson, I will be sharing a word problem about solid geometry and try to answer along with me to understand it better. So let us start. The question is about a dog tied to one of the corners of a rectangular building using a chain that is 40 feet long, and the dimensions of the building are 30 feet by 20 feet. If the dog can reach wherever its rope allows it to reach, what is the maximum area the dog can cover? So let us begin by illustrating the word problem to give us a better idea on how we are going to solve the problem. So looking at the illustration, we can get these values as our given. We have the width of the building, which is 20 feet, the length of the building, which is 30 feet, the length of the rope, which is 40 feet, which is equal to the maximum reach of the dog. So the problem asks us to solve for the maximum area covered by the dog. So we use this formula where we get the total area by adding areas 1, 2, and 3. And based on the figure, we are going to solve the area of a circle. And we know that the area of the circle is equal to pi times square of the radius. We then get the maximum area that the dog can cover, which consists of the following areas. And please note that the value of the following areas will not be rounded off in order to have an approximate value when we total the areas. So the area 1 is 1/4 of a small 10 feet radius circle on the top. So we multiply the area of a circle by 1/4 and get an area of 25 pi square feet. The same thing for area 2, which is 1/4 of a 20 feet radius circle on the left, which has an area of 100 pi square feet. Lastly, the area of 3 is 3/4 of a big 40 feet radius circle. So for area 3, we are going to multiply the area of the circle by 3/4 and get an area of 1,200 pi feet squared. We then add these computed areas and get a total area of 1,325 pi square feet, or approximately 4,162.6013 square feet. Therefore, the maximum area covered by the dog is 4,162.603 square feet.
Greetings everyone, I'm Bernadette Cavalas from Group 1 and here I am again giving you one question with solutions from solid mensuration. So the first question is, the area of a trapezoid is 36 meters squared, while its altitude is 2 meters. The bases have a ratio of 0.8. What is the length of the longer base? So I'll give you time to compute for the answer, or you can just pause the video for the computations. So with that, let's proceed. As we all know, a trapezoid is a quadrilateral with one set of opposite sides that are parallel. And the parallel sides are A and B are called the bases. And as per given, we do have here area which is equal to 360 meters squared. And the perpendicular distance between them is the altitude of the trapezoid, which is from the given it is equal to 2 meters. So to solve this one, from the area formula of a trapezoid, which is A is equal to 1/2 A plus B times H, and from the given ratio of the bases, which is A over B is equal to 4.4 or 0.8. So we can equate for A, which is equal to 4/5 times B as our equation 1. And from the area, A is equal to 1/2 A plus B times H. So we got 360 as the area, 1/2, 4/5 B plus B times the altitude, which is 2 meters. So we can get 36 equals to 9/5 times B. So we can then equate for B, which is equal to 20 meters. Substituting B to 1, we can get A is equal to 4/5 times 20 meters. So A is equal to 16 meters. This makes the two bases be equal to 16 meters and 20 meters. So, from what is asked in the problem, how much is the longest side, we can then say that the longer base is 20 meters. That's all, and I hope you learned something. Thank you.
Good day, listeners. I am Adrian Del Pilar, and today I will be discussing to you three problems related to solid mensuration. For our first problem, a vessel in the shape of a cube measures 1.65 liters. On a side is tightly packed with 8 balls and full of water. All balls are identical and are in contact with the walls of the vessel and the adjacent balls. What is the volume of water in the container? To better visualize our problem, we prepared a figure for our problem over here. Okay, so as you can see, the vessel is shaped into a cube, and each side of the cube is measured to be 1.65 meters. Inside the vessel are 8 tightly packed balls. Okay, so each face you can see 4 balls that are identical. Okay, let us proceed to our solution. Let R be the radius of each balls. Let VW be the volume of water inside the vessel. Let VV be the volume of the vessel. And let VB be the volume of each ball. Okay, so going back to our statement earlier, since there are 4R in our second picture over here, which is equivalent to X, or 1.65, in order to get the individual radius of each ball, we will divide 1.65 by 4, which will give us 0.4125 meters. Going back, we are trying to look for the volume of water inside the vessel. In order to get the volume, we will subtract the volume of the vessel to the volume of each ball. Since the vessel is shaped into a cube, we will be using the formula for the volume of the cube, and then the volume for the ball will be the volume of a sphere. As you can see here that volume of the cube is x cubed, and then our volume of the sphere is 4 over 3 pi r cubed, and then we will multiply it by 8 since there are 8 balls inside the vessel. Okay, so plugging in our values, which is 1.65 to the power of 3 minus 8 times 4 over 3 pi multiplied by 0.4125 to the power of 3 will give an answer of 2.14 cubic meters as our answer, or the volume of the water. For my last problem, the length of one side of a rhombus is 33.3 centimeters. One of the interior angles measures 60 degrees. Find the length of the longer diagonal of the rhombus. So to better visualize our problem, we have here our rhombus, and we are already given with the angle, which is 60 degrees. And opposite angles in a rhombus are equal, and all angles inside a rhombus will equate to 360 degrees. Using this equation, we will be looking for the wider angles, or the measurement of the wider angles, dividing it by 2 to get the individual angles, which is equivalent to 120 degrees. As you can see in our diagram, it forms into a triangle. So we can get the length of the diagonal by using the cosine law. Since we are already given with the length of the sides, which are 33.3 centimeters, we will be using this equation where c squared is equal to a squared plus b squared minus 2ab cosine of c, plugging in our values for a and b and cosine of 120, which will equate to 57.6773 centimeters, which is the length of the diagonal of our rhombus. Simple or very simple?
Okay, so we have the problem here where to calculate the perimeter of an ellipse if the length of the major and minor axis are 67.8 centimeters and 26.98 centimeters respectively. So since it was mentioned that they were the major and minor axis, so we're gonna find where to get the semi-major and semi-minor. So for semi-minor, we have 26.98 divide 2 will be 13.49 centimeters. And for our semi-major, 67.8 divide 2, we'll be having 33.9 centimeters. So we're going to use the formula to get the perimeter of an ellipse, 2 pi times the square root of a squared plus b squared over 2. So by substitution, so we can get 162.107 centimeters. So we have here what is the value of each interior angle of a regular pentagon. Given that a pentagon has 5 sides, so we'll be using the formula to get the interior angles. So n minus 2 over n times 180 degrees. So by substitution, we can get 108 degrees. And since the choices was in radians, so we're going to convert 108 by multiplying pi over 180. So we can get 3 pi over 5.
Hello, my name is Dessa. The next problem that we have right here is the length of the sides of a triangle circumscribed by a circle is 10 centimeters, 15 centimeters, and 24 centimeters. Find the radius of the circle. So to illustrate this problem, we have right here the triangle that is circumscribed in a circle with the lengths 10, 15, and 24. The broken line right here represents the radius of the circle, which is what is asked in the problem. So for a triangle circumscribed in a circle, we can use the equation AD, or the area of the triangle, is equal to ABC divided by 4R. And we all know by using the Heron's formula that AT is equal to the square root of S times S minus A times S minus B times S minus C. As but before we can use this equation or this formula, we need to find the semi-perimeter of the triangle, or the S of the triangle, which is equal to A plus B plus C divided by 2. So to solve the semi-perimeter, we just substitute the length of the side of the triangle to this equation. So 10 plus 15 plus 24 divided by 2, we have our semi-perimeter as 24.5 centimeters. So we can now already solve for the radius of the circle by equating these two equations. So the Heron's formula is equal to ABC divided by 4R, and by simplifying this and isolating R, we can have this equation. We can now substitute this and input this in our calculators so that we can arrive at a value of 21.9093 centimeters, which is the radius of the circle. That would be all. Thank you.
For our next question, we are to find the volume of the solid shown below. So we are given with a frustum of a right circular cone with the upper base diameter of 14 feet, lower base diameter of 24 feet, and the slant height of 13 feet. So why is it called the right or the frustum of a right circular cone? So the height shown in the picture is perpendicular to the upper base radius and the lower base radius, and it forms a right angle. So that's why it is called a right circular cone. So we are to investigate the given of the problem. So we have here the upper base diameter, D1 is 14 feet, the lower base diameter, D2 is 24 feet, and the slant height is 13 feet. So to solve for the volume of the frustum of a right circular cone, so we are given with the formula of IH over 3 times the quantity of R1 squared plus R2 squared plus R1 times R2. So for R1 and R2, we are to divide 14 feet and 24 feet by 2. So we're given with R1 is 7 feet and our R2 is 12 feet. So since we are given already with R1 and R2, however, H is still unknown. So we solve H using the slant height formula. So our slant height formula is given as the square root of H squared plus R2 minus R1 squared. It is derived from the Pythagorean theorem. C equals the square root of A squared plus B squared. So our A here is the height, and our B is the difference of R2 minus R1, and our C is the slant height. So we are to substitute the values. Our L is 13 and our R2 is 12 and our R1 is 7. And we will use our calculator to shift solve H. So we're given with the answer of 12. So we are already complete with our values for the volume. So we are to solve the volume, and we will derive at an answer of 3,488.8847 cubic feet.
Good day everyone, I am Roy Christian Oro and I will be solving this problem. The arc length intercepted by a central angle is 3.5 inches, the radius of the circle is 1.5 inches, find the area of the segment intercepted. So if you draw the figure, this is what it would look like. Then red and yellow, that's the area of the sector, and the area of the segment, which is what we want, is the red portion only. So to get that, we have to subtract the area of the sector with the area of the triangle, and we get that theta is equal to S over R. So it is equal to 2.3333 radian. Then we can now get the area of the sector, which is 1/2 R squared theta. So we get a value of 2.625 inches squared. So now we can get the area of the triangle. So it is given by the equation 1 half AB sine theta, where theta is the included angle and AB is the radius in this figure. So we get a value of 0.8135 inches squared. So we subtract the area of the sector with the area of the triangle, and we can get that the area of the segment is 1.8115 inches squared. That is all. Thank you.